Hello students. So let's continue with the MCQs. The first MCQ for today is, the stars appear shifted from their actual position due to the phenomenon of, there are four options: diffraction of light, scattering of light, refraction of light, and reflection of light. And if your concepts are clear, I think so you should not have any difficulty in choosing the correct option. It is refraction of light. Let's recall now. I've drawn a rough figure here. So we have an earth, we have an observer who is standing on the earth, okay? And then these two layers are actually layers of atmosphere. Here for simplicity, I have divided the atmosphere into two layers. Otherwise, we know that we can assume that Earth's atmosphere is made up of different layers having different optical densities. That means they have different refractive index values. And we can actually draw 4 to 5 layers instead of 2 layers. Okay? And always when starlight enters into the atmosphere, it passes through the atmosphere. It always, when it enters from one layer into another layer, it always travels from rarer into denser medium. It means the layer which is lying closer to the earth is optically denser than the layer of atmosphere lying away from the earth. So if we choose these two layers, we have drawn two layers only. So the layer closer to earth is optically denser and the outer one is optically rarer compared to it. So here star is drawn. So actual means actual position of the star. Starlight is entering into the atmosphere. When it enters, small dotted line is normal. We know whenever we have a circle or a sphere, okay, then the normal means radius at that point. Okay, so I have drawn a small dotted line which indicates normal here. So the ray, as it enters into the atmosphere, it will bend towards the normal. Okay, because we know in space speed of light is maximum, and when it enters into the atmosphere, the speed decreases. So it enters from rarer into denser medium. It bends towards a normal. Again, when it enters from this layer into the second layer, which is lying closer to the earth, as I have told you before, the optical densities are different, and the layer which is lying closer to earth is having more optical density, that is, its refractive index value is more, or we can say speed of light is lesser in that layer. So again, the bending takes place towards a normal. So here, for an observer, this is a ray which is reaching observer, which is actually coming from star. Now, if you extend it backwards, as I have done it by using dotted line, and extend it till a point above the star, that is the apparent position of the star. Star is actually lying below, but due to this bending, okay, due to this bending, for an observer, it appears to be above its actual position, which is called as apparent position of star. So we know this happens due to atmospheric refraction of light. Hope it is clear. Now, the next MCQ is, no matter how far you stand from a mirror, your image appears erect. The mirror is likely to be, yes, there are 4 options given: plane mirror, concave mirror, convex mirror, and the last option is either plane or convex mirror. We know that in case of plane mirror, we always get virtual and erect images, because when you stand in front of mirror, whether you stand close or far away from a plane mirror, your image is always erect and virtual. And second is concave. We know that concave mirror is a converging mirror which can produce real inverted as well as virtual and erect images. If you recall the ray diagrams, you should know that when the object is lying between focus and pole of the concave mirror, then only virtual erect images are formed. Otherwise, for all object distances, images are real and inverted. Convex mirror, we know it is used as a rear view mirror in vehicles, and we know that we always see virtual erect diminished images in the rear view mirror, it means in convex mirror. So convex mirror and plane mirror, both of them, they produce virtual and erect images. So the last option D, either plane or convex, is the correct answer. But you should remember that what is the difference here? In plane mirror, the image is of same size as that of object and the image lies as far behind the mirror as the object is in front of it. But in case of convex mirror, always the image is virtual, erect and diminished, or it may be highly diminished when the object is at infinity. Okay? And secondly, the image always appears to be closer than the object is. Hope it is clear to you. So D is the correct option, either plane or convex. Now the next MCQ is, 3 rays of light fall on a converging lens as shown. So 3 rays are incident at the convex lens. We know it is a converging lens and we can see that the rays are parallel to one another, but they are not parallel to the principal axis. Which diagram shows the path of the rays after passing through the lens? So we have to choose the correct ray diagram. So these 4 diagrams are drawn here. We can see in all the 4 diagrams, incident rays are similar. They are parallel to one another but not parallel to the principal axis. Now, you should not have any difficulty in choosing the correct diagram if the diagrams are clear to you, if the concepts related to the ray diagrams of convex lenses are clear to you. We know that if we see the middle ray, center ray, that is actually incident at optical center of the lens. And we know that whenever incident ray or any ray passes through the optical center, or it is incident at optical center, it goes undeviated. It means it does not bend. In case of A, the ray is bending. In case of C, here it is bending, center ray. Look at the center ray. It is bending. In case of B, again it is bending. In case of D, also the center ray is bending. In case of C, the center ray, that is ray passing through the optical center, is going undeviated without any bending. So C is the correct option. Hope it is clear to you. So C option is correct. So we'll continue with the MCQs in our next video. Goodbye students. Thank you.